Hi and welcome. My name is Joel. You can call me Teacher Joe. In this video, we are going to discuss about the equation of a straight line. Please let us move together, and I hope this video will help you in understanding how to plot, how to find the equation of a straight line using points, how to solve problem involving equation of a straight line, say intersecting perpendicular lines, parallel lines, and what have you. So let us go and let us start our video. First of all, we're going to discuss about the length of a line segment. The length of a line segment equals to the magnitude of that length or of that line segment. And to get that length, we are going to get the coordinates at the ending point, subtracting the coordinates at the starting point, that is the ending point x2 and y2, and the starting point x1 and y1. We subtract them like this, x2 minus x1, and that one squared added to y2 minus y1 squared. So after that, when we substitute, say, with the points a equals 1, 2 and b equals to 4, 6, then we are going to get the length of that line segment will be equal to 4 minus 1, where 4 is x2 and 1 is x1, and that one squared added to 6 minus 2, that one squared. Then we find the square root of the result. So in this case, in this case, the square root of 25 gives us 5 units, which is the magnitude of that line segment. Let us go ahead and discuss about the midpoint of a line. Say, our typical example, AB, the midpoint of line segment AB will be equal to, we take the difference in the starting and the ending points, then divide by 2. For example, this will be x2 minus x1 over 2 and y2 minus y1 over 2. This one will give us the x coordinate, and this one will give us the y coordinate of the midpoint of this line segment. Now let us move ahead and discuss about the gradient of a line. We all know that the gradient of a line or gradient of everything equals to the change or the rate of change at which that thing changes with time. For example, if a line is sloping, then there is a rate of change in the y coordinates and a rate of change of the x coordinate. So if we take the rate of change of y coordinates up on or divided by the change of x coordinates, then we are going to get the gradient of that line. Taking our example of line segment AB, where A is 1, 2 and B is 4, 6, then the gradient will be equal to 6 minus 2 all over 4 minus 1, which is 3 over 4. That is the slope of that line, or the rate of change of y and x axis of that line segment. Let us also discuss about the equation of a straight line. And to obtain the equation of a straight line, we need to get the gradient. That means y2 minus y1 divided by x2 minus x2. That is how we get the gradient. Then we go ahead and find the equation using 1 point. For example, let M subscript AB be the gradient of line AB. So our M subscript AB will be equal to 6 minus 2 over 4 minus 3, which is the gradient of our line AB, which we found earlier here. Then to get the equation of that line, we use 1 point. So we take y, subtract the y coordinate or the y point on that chosen point, maybe the starting point or the ending point, over x, subtract the x coordinate of that point, and we equate that to the gradient. Then after cross multiplying, we get our equation of a straight line. For example, in this case, we will take y minus 2 multiplied by 3, we are going to get 3y minus 6. Then that will be equal to x minus 1 multiplied by 4, which will be equal to 4x minus 4. So 3y equals to 4x minus 4 plus 6, which is equal to 3y equals to 4x plus 2. Writing the line AB in standard form, where the standard form is y equals to mx plus c, where m is the gradient and c is the y-intercept of that line, or the constant point where the line cuts the y-axis. Then our equation of that line will be equal to y equals to 4 over 3x plus 3 over 2. So the line segment cuts the y-axis at the point 3 over 2. And if you can see here with my little sketch, you see that this line cuts the y-axis at this point, and we know that 3 over 2 is equal to 1.5. So this is my rough sketch, but roughly you can see that this line here cuts the y-axis at a point in between 1 and 2, which to be accurate, that will be 3 out of 2, or 1.5 units. Now let us have some few facts about straight lines. The gradient of parallel lines is the same. If we have line AB and another line PQ, then if these two lines are parallel, the gradient will be the same. If the gradient for line AB is 4 over 3, then the gradient for line PQ will also be 4 over 3. If PQ is perpendicular to AB, then the product of their gradients gives us -1. And whenever we have a straight line, the y-intercept of the line occurs at the x-axis, equals to 0, and the x-intercept of the line occurs at the y-axis equals to 0. The point of intersection of two lines can be found by solving the equation of the lines simultaneously without drawing. Let us have a look at my drawing. Let me put this guy here. Now we have my sketchy drawing. If we want to draw a line or a straight line, then we need to get at least 2 points of that line. And from the beginning, this line AB, we had a point 2, 1 and 6, 4. And if we can use the same equation, the equation of a straight line, AB, then we will find that 10x is also a point on that straight line. So plotting the straight line on a Cartesian plane, we have to find when y is at 4, then x is at 1. So we're going to, when y is at 2, so we're going to look at where 2 is, then we find 1 on the y-axis, on the x-axis. So this is our point x, y, which is 1, 2. Then another point 6, 4, we're going to, on the y-axis, 6 is here and 4 is here. So when we do a rough sketch of that line, we find that this is the straight line and it has a positive slope, meaning that it is slashing forward. It has a positive slope. Another lines will have negative slope and this will be slashing backwards, and some other line will have a gradient of equals to 0, or you'll see some amazing things. So thank you. If you like this video, give it a thumbs up, share and comment. See you next week. Teacher Joel. Bye bye.